Hi, I'm Jeff Franke, Editorial Director of Manufacturing.net and Manufacturing Business Technology. Welcome to Security Breach. So, my daughters, they like to give me a hard time about getting old, and I use it as an opportunity to showcase the fact that while I've been around for a longer time, that means I've seen more, I've learned more, and I have a broader understanding of how things work. Now, trying to pass this along to them in a way that shows that they can take advantage of all the benefits of my age, well, that's kind of an ongoing struggle. Said another way, I'm a legacy asset, just like most of the devices many of you observe, manage, and secure every day. Your machines are still in place because they work. And while the technology around these assets has evolved, their core functionality and value to the production process has remained constant. But as sensors, network connections, and access parameters have all been upgraded to improve output, these highly prized pieces of equipment are showing their age from a cybersecurity perspective. The challenges they present are reinforced with findings from Fortinet's 2024 State of Operational Technology and Cybersecurity Report. A couple of key takeaways include findings that show nearly 1/3 of respondents experiencing 6 or more intrusions in the last year. Previously, only 11% cited that many security incidents. This can be credited to an ever-expanding threat landscape brought about by more IoT-type connections to legacy equipment. Additionally, fewer respondents claimed 100% OT system visibility, with that number decreasing from 10 to 5%. On the bright side, we're getting better in some areas. Just like my fishing tackle box has grown and improved with age, the report states that OT security posture continues to advance in the right direction. This includes 20% of organizations establishing visibility and implementing segmentation, up from only 13% the previous year. Additionally, the highest level of security posture maturity showed year-over-year growth from 13 to 23%. Here to help sort through some of these ongoing challenges is Jon Taylor. He's Director and Principal of Security with Versa Networks. They're a leading provider of digital transformation and edge security solutions. Jon, thanks so much for joining us today, and welcome to Security Breach. So, Jon, again, thanks so much for joining us here in Security Breach. Really appreciate you taking the time. Let's jump right into one of the bigger conversations we always have here on the program, and that's just talking about vulnerabilities. There's a lot of new stuff popping up. I get the CISA updates. I'm sure you do as well. Most of our audience does. Let's talk about what some of the more popular ones you're seeing right now, and what's the relation to some of this legacy equipment that we know continues to be a challenge in the OT sector.
Well, even above and beyond vulnerabilities, right? I mean, we can sit there and hash them out all day. I mean, everyone's kind of putting out their own updates to it. One of the things that we see from vulnerabilities as a whole, right? Especially in the IoT and the OT space. Is that we don't see a lot of patching going on, so I'm not going to sit there and pinpoint a single vulnerability or a couple of vulnerabilities that really kind of hit mark, right? Because the difference is that when we start looking at manufacturing, when we start looking at things like oil and gas industries, energy, utilities, and things of that nature, everybody's on some type of different patch level. So we don't know what could be vulnerable, right? We don't know what is vulnerable at that point. We don't know what could be out there for people to look at. What I kind of focus on when we start seeing more and more vulnerabilities like this is I start looking at a customer's architecture. I start looking at things, right, that could potentially be out there, and saying that, hey, we definitely want to make sure that number one, we're patching, as we can be patching, but we also want to make sure from an architectural standpoint that we're putting the right controls in place. We're putting firewalls, we're putting, things like zero trust network access, which has historically never been allowed, especially in an OT space. But we've got new technologies out there. We've got things that actually look at, our OT side. We have the ability now to be able to bring these newer controls in place that we might not be able to, like let's take OT equipment specifically, update and patch OT equipment, because if we do, we are going to break something. So we have to look at it from a network perspective and how we can better secure that device and catch said vulnerabilities from a network perspective and prevent them from ever reaching that endpoint device, right? So it's more on the architecture. It's not just from a vulnerability or a specific vulnerability or patching or something like that.
Yeah. So when it comes to that architecture design, we're constantly having to reimagine it or re-understand what we have because there's more stuff being thrown at it. Now,
Of course.
is from a strategic perspective, do we have more of these vulnerabilities than popping up on the network because we don't have the visibility we should have, or is this still linking back to a lot of the fact we still have so much legacy equipment out there that wasn't designed with security protocols in mind?
So I like to call it archaic because that's about the right word. Yeah, I mean, it comes back down to that. I mean, look, I cut my teeth in IoT, or what we now know as IoT and OT. I've done a lot with medical and IOMT in my career, and it's interesting to see, like, I used to do design work. I actually started out being a drafter and doing design for electrical and so forth, building motor control centers, right, or designing motor control centers. How we got those online was we just slapped the circuit board in and slapped a PCI card in with a NIC and said, hey, this thing's online, and watch it run. How do you update that? You can't, right? It's impossible. And then thankfully, we fast forward 20 years. Yes, I'm that old. The gray in my beard, kind of makes me, ache my bones or something like that when I say it. But, realistically, it's, we fast forwarded, and you have companies like GE, you have companies like, Honeywell and so forth. They're starting to build a lot of this stuff with security in mind and have it be patchable, right? But then you still have an industry that says, if I patch that and it goes down for some reason, I lose millions of dollars, in minutes and hours of manufacturing. So they still don't do it. So you've got to look at something. That's the reason why I come back to that network and that architecture side, right? Because if I can't do it on the end device, right, and patch that end device in such a way and keep it up to date, then I have to look at a network that can be adaptive, that can find and see and sense things like the common vulnerabilities that are coming out, right? The more severe vulnerabilities that are starting to hit market, and be able to prevent that type of traffic, those payloads, anything of that nature coming even into the network, or it being called out in such a way that it would even download its own payload and then be a place where a malicious actor could come in and make it a jump point or do data exfil, or even worse, weaponize, right, IoT and OT in some way, right, where it could actually harm a human.
Yeah. No, lots of interesting dynamics there, like you said, with you said archaic. That's your term. I try to be a little nicer, a little more sensitive there, but I can't argue with you in some cases. And that kind of leads into this other issue that we have. Depending on what stat you want to look at, manufacturing, the industrial sector, either the number one or number two most targeted sector that we have right now from a cybersecurity perspective. We know a lot of these issues. You just talked about some of these giants in the industry still not really responding to a lot of the threats that are out there.
Yeah.
What do you think are some of the biggest issues we have in just terms of getting a handle on this and really being more proactive and moving more quickly so we can get knocked down that list a little bit and not be so highly targeted or highly attractive to hackers?
So I think there's a couple things, right? So and I focus my career is plainly on the network, right? I do a lot with, everything from next gen firewalling to however, but, I also focus too, right, being in security on, regular patching and just keeping systems and things like that. So I think there's a twofold process here, right? Number one is, let's take manufacturing, because I look at three majorly target industries, and I keep medical in that as well, with all the IOMT, type of devices, right, and whatnot that are there. Number one is that, as manufacturers come in and start and are building their solutions, right, it's a forever evolving, space. The downside to it is, once again, we have a lot of that archaic there because, MRI machines, right, cost $1 million, right? Let's look at, manufacturing, facilities and so forth are millions of dollars. Legacy equipment, you can't refresh that like you can, an Amazon device or however, right? It's just not feasible, right? When you look at oil and gas and energies and things like that, the systems were designed to last, 20, 30, 40, 50 years. They weren't designed to be thrown away after every 5. So as companies are coming in and building toward that same motto, where these systems work for 20, 30, 40 years, and as corporations are taking investments that they've made over time and bringing them onto the network, we have to look at, from a security aspect, number one, how do we design for future patches in such a way that it doesn't hinder productivity, right? Can I patch on the fly? Can I keep something running without maybe having the brain actually work? And then therefore I can continually patch the head-end node, or I can continually patch the control center, the brain, however that is, on a regular basis. Like let's take there's systems out there that might still be running Windows 2000 because the way it was built, if I upgraded to Windows XP to Windows 7 all the way up to Windows 11, it breaks my communication with that IoT type device. We got to keep in mind, how can I continue to go further even though that device may not be upgraded in the same in the same fashion, and then keep the lines of communication segmented in such a way that only control communication goes across, right? Only certain communications that need to access that device goes across, while we're able to actually, physically from a networking perspective, protect that device from ZTNA, right? Either on the wire or whether it's coming through Wi-Fi or however, be able to protect that device so it alone doesn't have the ability to call out. It alone doesn't have the ability to be compromised because it cannot be patched but maybe 2 times a year. So I think that's number one, right? And then on number 2 is we dive further into that architecture where we're saying, from a manufacturing aspect or from an oil and gas or however, we have to have continuity of business, right? We can't take the plant down. We can't take something like that offline. So we have to have systems that we can routinely upgrade and build redundancy into, that if I upgrade a switch, if I upgrade, a firewall, a router, however that is, I can be able to do that in real time in such a way that the plants don't go offline and that the equipment still runs autonomously if communication is something like that, it is broke, right? And I think that from a networking perspective, we've been able to do that now, primarily about what we've done in the enterprise space and things like that, because we take that redundancy in mind, but we're still not tackling what we're doing from an OT and a device perspective, as well, because we're just now starting to architect for that and build these machines to have redundancy and have systems in place that allow you to do that.
Well, that's interesting. We always talk about secure by design. And in some cases, when for products, we talk about design for manufacturing, it kind of feels like you're talking about combining those, and design for patching, essentially, is what we need to put forward there. And that's interesting. To oversimplify, are we almost talking about, as part of that, like an embedded micro-segmentation type of approach to that?
That's where I kind of lean toward, right? Is being able to do an embedded micro-segmentation. I also say, I don't say design for patching, I say more like design for continuity. Think about it like that, right? It's device. I use this example quite a bit, right? So if I'm in a car manufacturer, for instance, I've got a robotic arm, it reaches over, it grabs the car door, right? And it pulls the car door on the side of the car and they weld it on. Great, right? So what happens if that arm goes offline for any reason? Well, we're going to have a lot of cars coming through without any doors on it because it's all automated at that point. Well, what happens if I need to upgrade or I need to update or patch the operating system on that arm? How can we have a solution in place? And I think, like I said, we've done this in the IT side where we can update like an offline hard drive, right? Or an offline, type of memory. And then we can flip to that, automatically, and we lose nothing, right? The continuity of business, the continuity of action still is there. You might have a millisecond of offline time, right? As it flips to the new code. But once again, right, we're able to continually patch and upgrade and have continuity of business because we have that. And I think that's where we've come in the IT side. But kind of putting that all together, right, is the micro-segmentation portion is that, yes, you are kind of designing to micro-segmentation on a network. You're designing to micro-segmentation within the own system itself. Because once again, I can upgrade that head end, but I have to make sure that only certain communication can go from that head end, that controller, that master computer, right? Whether that's to an MRI machine, whether that's to an automatic guided vehicle, whether that's to an oil drill on an oil rig, however that is. I've got to maintain that level of communication, right? Is only sending, what it needs, right? And not erroneous communication to it. And then in that process, I also have to have that micro-segmentation set up on the network to say, if that box sends something that it shouldn't send, we block that at the device level, right? At the switch port, and say, you're not allowed to do this. This device is protected. And if it is compromised, the blast radius for that device is now limited to the device and not east-west.
Yeah, brilliant strategy. We just need to get there, get a little more buy-in on it. Where does that come into play, though? Is that the responsibility for the user to push it? Is it the responsibility for the supplier to push it? Is it a team effort? How do we get there, I guess?
Good question, right? Believe it or not, I've had a lot of people ask me that, here recently, in multiple different things. I'm going to go with, right. It's a combination of everything. Across the board, I don't think anyone has any more, onus to that than not. I think it's something that, and being on the customer side and growing up in that space on the customer side, it wasn't something that I was really kind of taught, right, being in an OT space, to really ask for, right? And I think that, if customers ask for it and demand it, I think that manufacturers will jump onto that. I think that manufacturers don't see it as a requirement today as much as they should be seeing it. So it's not something that a lot of people architect for. So it's kind of a loss on both sides of that. And I think that even from a practitioner side, being whether you're on the consultancy, you're on the implementation part, right? You're on the design aspect, right? Working for whether it be resellers or however that is. I think even from our side, we still design to kind of the legacy standard. We don't think outside of our box when it comes down to how we treat IoT and OT, type devices. And so, we've gotten, for the lack of a better term, we've gotten comfortable with it. And because we get comfortable, we kind of just stayed in the little realm and air gapped our systems and said, this works. And I think we're seeing more and more interconnectivity, especially with companies like Honeywell and so forth, who are selling more managed services for their devices like PLCs and so forth. You have to have that B2B connectivity. You have to let them in. That's opening up holes that we've never seen in the industry before.
Yeah, we get so excited about the capabilities and the functionality that sometimes we lose sight of that blocking and tackling and keeping it secure. It's an interesting dynamic, and it continues to be sort of an ongoing challenge, if you will, as the attack surface just grows and grows. One of the things that's growing too in manufacturing, we're having a lot more conversations about edge computing, bringing this data to the edge. Well, you were talking about partnerships before with suppliers. Now we're looking at a lot of these cloud suppliers to sort of make those same movements. I know you deal a lot with SaaS, or Secure Access Service Edge. I always struggle with that acronym for some reason. But can you talk? Yeah, SASE. Okay, there we go.
Always enunciate the E. That's how you remember it.
Talk to us a little bit. What does that mean to you? What have you seen in terms of the escalating need for it and the conversations you're having with the industrial sector about securing the edge?
So first off, right, let's say that SASE is comprised of a couple different things. The actual textbook definition is it is SD-WAN, right, or software-defined wide area network. That is the medium, right, that everything rides on. I always talk about there's a reason why we got here and what SD-WAN really is. We're really breaking away from our MPLS days, right? How we've built networks, how we've interconnected side. Customers are looking for low-cost ways to provide transport now. Local, direct internet access is probably the way to go with that, because I can get low-cost bandwidth, but I can't get guaranteed SLAs. I can't get guaranteed throughput because it is the Wild West. It is internet. So SD-WAN is what was brought in to or developed to really help with that, to interconnect offices, provide multiple paths, and basically give you MPLS-like functionality over the web. We've taken that and we've built out this thing called SSE, or Secure Service Edge, right? And we've said, why should I have a bare metal firewall at every single one of my locations, right? We've reduced cost of ownership, right? But I can have anything that is northbound. So all of my internet-bound traffic, whether that's going to something like an AWS, right? Because I still have to go to the internet for that. Something that's going out to my CRMs or any type of SaaS applications. I just want to go to YouTube, however it is. I need to protect that, and I have to do that traditionally with the bare metal. Secure Service Edge puts that in the cloud, and then you do secure connectivity to it, right? And so SASE is the combination of both of those together, and then you have other aspects of SASE where they come in and they have, of course, unified SASE, single vendor SASE, all this type of good stuff. Yeah. There's a lot of providers out there doing that, but being able to interconnect that and then having something in the cloud that's scalable to me. Now I don't have to go out and buy this big massive $250,000 firewall. I can actually buy it as a service, directly connect to it, provide all of my northbound traffic to that, and then it's scanned and it's elastic. If I need 10 gigs, I get 10 gigs. If I need 500 meg, I get 500 meg. If I need 100 gig, I get 100 gig with it, right? I just have to buy it as a service, consume it as necessary. I own all of the configurations and things like that, as my organization. So I'm still compliant, but I depend on the organization to keep it up to date. On the flip side of that, patching becomes better because now I'm in a redundant solution. I can continually keep it patched. I keep it up to date to the latest and greatest. And guess what? I'm never offline because I can dynamically be moved right within that cloud as necessary as systems get updated. And I don't have to worry about my N-X patch schedule or my two maintenance windows a month, right, at a facility to make that happen. So it's actually taking us especially in the OT space or the IoT space, it's taking us to a place now where we can keep continual patching, keep business continuity in place, while also being able to make sure that we're on the latest and greatest security. So if there is like a CVE, if there is a O day or a 0 day that's coming out, if there is something that's coming across, we can potentially catch that at an alarmingly fast rate. We can remediate it. We can even block it, right? And then we don't even have to worry about a blast radius any longer because I've prevented that from ever getting to the endpoint and the end user, right? Or the end device if it's an OT device trying to call out for something like that.
So what are some of the bigger obstacles preventing more manufacturers from putting that in place? Is it a cost thing? Is it it's another step? What are you seeing?
We all know the term air gapped, right? I think in some way, shape, or form. So I can say, right, from a very large manufacturer that I worked with, years ago, and I was actually a customer at, each one of their sites were air gapped. They had a data center on site, right? They did have local internet connectivity. They had firewalls. And then they had an MPLS where they would, from a data center perspective, you could interconnect, but from the site itself, the site was not connected. And so, we still see a lot of that going on. In the industry, at least I do from a manufacturing perspective. Oil and gas, I'm seeing them, embrace this a little bit more, believe it or not, with like oil rigs coming across satellite connectivity. It's becoming a lot easier for them to get to get data and to get bandwidth there. So certain organizations are adopting it a little bit faster, but we still have this, this, I call it a mentality almost where this facility can't talk to that facility, right? So A can't talk to B and B can't talk to C, but they can all talk back to the data center in some ways. And then we do our micro-segmentation in our data centers. And it's like we really are seeing now, and I'm seeing some customers, primarily potentially in the energy space, right? That are saying, I need to have my substations talk together. Transportation industry, I need to have, these particular different substations that I have talk to each other, right? Versus it being, air gapped and so forth. So I think that's one of the biggest things that's actually keeping us is that legacy architecture and that air gapped. And if anyone knows it, it's or if you know it, like it's the IEC 62443 model, right? We all call it Purdue, right? That's where it all founded. But I think we still architect to that, and we still treat that as a quote unquote Bible kind of, at the end of the day, like this is the document that we live toward. This is the architecture that we live toward because it's compliant. And if you go back and look at that, most of that architecture is air gapped from each other, right? They have very small connection points and it's very secure. And it's a huge stack of firewalls and security that go in place to do that. So that's the very long-winded way of saying, I think that's primarily what what's halting us, right, from adopting newer technologies, especially something that can do interconnectivity like what SASE and SD-WAN and SSE and stuff like that can provide.
Well, and we can talk about the legacy approaches. I'm fearful that in some instances it's legacy mindsets and sort of cultures that want to work in silos. They can say, we can't talk to those other areas. Well, they may not want to because they're afraid of giving up control of data, whatever you want to call it. I think that's an embedded just mindset that we're still struggling with in the industrial side too.
I was being a little nice there, but I completely agree with you. I'm glad you said that, other than me. It is, right? And I mean, look, I know administrators who sit on the plant floor of certain companies, and they're in their 50s and 60s, right? And it's like, I don't want to do this. My system runs great. I've never had an incident. And I asked him, I was like, how do you know you haven't had an incident? And it's like, and then they start looking at me funny. It's like, do you have the tools in place for that? This is the reason why you need to go and look at, whether it be a converged networking or just at least new tools that can give you that visibility. So I completely agree with you. There's a lot of people out there right now that's like, I'm not changing anything. I don't want to. That is hard. That is, and it's not necessarily an age thing. It's that industry side too. It's like, if I change this, I'm going to take manufacturing and continuity down. And no, we're not doing that. It runs. It's good. Hey, I got a firewall. I'm okay, right?
Yeah. Paradigm shifts are hard to break, regardless of the sort of walk of life you're in, without a doubt. So, you're going to a huge sidebar there. But Jon, you were talking about tools. Maybe you can talk to us a little bit about Versa and some of the things you guys are up to.
Yeah, so Versa is the industry leader, right, in what we call unified SASE. Remember how I talked about we have single vendor SASE, we have the unified SASE, right, and things of that nature. So we do unified. Our solution is built on one operating system. So whatever we deploy in the cloud is the same thing that we deploy on-prem. And what that means is that yes, we have next-gen firewalls. Yes, we have SD-WAN. Yes, we have solutions that can provide that from an on-premise and interconnectivity standpoint. But because of Versa, and hence the name Versa, our solution is so versatile at the end of the day, we've been able to build this in a platform out in the cloud, right? So we partnered with Equinix. I'm not telling you anything I shouldn't be saying, right? This is what we tell all of our customers. We did partner with Equinix, right? We do have many data centers, right? Many points of presence out there. But because we deploy the same OS in the cloud as what we deploy on-prem, we have the ability to run SD-WAN, right, as a medium, even up to the cloud, which a lot of other providers can't do. So it looks like your own private network. You get to see your own estate, right, and things of that nature. What's really cool about that is that everything that we run in the cloud, right, becomes scalable. It's elastic. So once again, I can have my firewall sit in the cloud. I can run private networks all the way up. So I'm not looking like I'm doing an IPsec or a GRE tunnel or something like that and having to have that extra overhead. I just run an SD-WAN tunnel up to the cloud. I have it be my front-end firewall. I have it do everything I want it to do for me. But I can also have it be tertiary routes if I need to hop through the cloud, whether it be for security purposes or just networking purposes or however. We bring that right to the customer and the ability for that because it's all running SD-WAN, even between our POPs. So like for customers, and this is one of the reasons why a lot of I would say manufacturing customers and a lot of energy customers and healthcare is starting to look into this as well with the multiple offices like MOBs and things like that that they have out there in the little clinics right out in the middle of nowhere where all they can get is just plain internet. A lot of customers are looking at us for that because now we're able to interconnect everything over the internet or like through the internet in a secure way. Have security doing east-west so I can see, not only just, my threats that are going out northbound. What happens if I get ransomware and it tries to propagate from facility A to facility B? We can block that right at the edge. What happens if it goes out to the cloud and I need 100 gig or 10 gig or however that is? We can actually send that to the cloud northbound. But for those other customers, right, that we were just talking about, like if I have to have a connectivity endpoint, right, from a B2B connection going out to Honeywell because they've provided me a service, I can now do that through the cloud, right, interconnect that, see all of that traffic pass in through the cloud into my facility, and I can guard that, block that, apply policy to that in such a way that's ubiquitous no matter where they come in from. It's always deployed in every single one of our POPs. So now I have ubiquitous security, both on-prem and off-prem. I'm having my traffic scanned in the cloud, and it never even has to hit my internal network, never has to hit that SD-WAN appliance. It never gets to me, even though it looks like it's on my private network in the cloud. It's still physically out there in ether land, right, at the end of the day. Yeah. So it's just blocked. It's dropped. Right, I don't have to worry about it. So that's some of the high level stuff like Versa's doing. We can get into the low level stuff all day. This is my sweet spot. I can talk about this, until the cows come home.
Yeah. It sounds like a moving sandbox, essentially. Wherever you need it, that's where it's gonna appear. Very interesting. One of the things, John, in leading up to this conversation, we were talking about a number of different things, and you expressed in an email about some of the concerns about critical infrastructure, and we've been talking about the legacy systems that are in place there. I'm kind of torn because I see a couple different trends here. I see a lot of hacktivists or state-sponsored hackers looking at infrastructure, whether it's water treatment, energy facilities, whatever, and attacking these outdated ICSs, and they're sort of putting out a blueprint, if you will, for other hackers then to hit the industrial control system. Obviously, that's a concern. That's a huge threat. But are they also sort of tipping their hand a little bit? Is this helping the industrial sector to also understand a lot of these other vulnerabilities within the ICS that maybe they wouldn't have looked at before? Which way do you see that going?
I think it's both, right? I think it's number one, it's incredibly dangerous. If I had to sit there and say what's my boogeyman that keeps me up at night is things like that. Yeah. So I will absolutely say that this is, attacking things like the energy sector, right, and so forth is probably one of the most dangerous things that we can possibly have. The other side of that is that from an OT perspective, we've never went through and done things like pen testing. We've never went through and tried to find the vulnerability, like you just said. So it is tipping the hand. It is helping us, right? The question is going to end up being is this going to be something that really is it something that the word I'm looking for is it more dangerous for us to allow them to continue to do what they're doing, right? As we're so reactive for it, or is this the turning point, right? And I can't answer this, right? I think the industry itself has to answer this. But is this the turning point where where the industry is going to start looking at itself, looking at how it's architected, right, for its ICS systems? And then is it going to start bringing in more of those IT controls, right, toward the end of the day? And then start also bringing in other grooming aspects like, are we going to start doing pen testing? Are we going to start, having cybersecurity, become the staple, right, within that solution, right, within that OT architecture, moving forward? So therefore, we can rapidly speed up, right, and catch these threats before they're happening. And I think this is a great turning point to be able to make that happen, because we're seeing more and more come out. Right now, we can actually go and we can architect to that, and then we can architect beyond that. Because if we're going to take solutions down and systems down to put those architecture in, now's the time to make it a robust architecture to where we can prevent future threats from coming in and be able to be proactive against that.
Yeah, no, I agree. It's an interesting sort of double-edged sword, because I've always been such a huge advocate of more transparency about these attacks and sharing more best practices. I think the advancements that the industrial sector in particular has made since Colonial Pipeline is enormous in terms of what's being shared. But like you said, there's still a lot to keep us up at night. What are some of the other trends that you're seeing right now out there? I mean, we haven't talked about that certain two-letter acronym that everybody wants to discuss. I don't know if there's other things that maybe you're seeing out there that are sort of lighting up your radar right now.
So you're talking about my artificial intelligence? I mean, is that kind of what it's out there? I got, if I crack open the head this way and pull it up, I'll be like Data from Star Trek. It's great. I think that's the biggest thing that's going forward. And so, look, I'll be the first to sit there and say I love AI. I think AI is great, and I think it's helping us in ways that we never thought possible. And so there's a couple aspects to AI, right? We're in this age where we like to call where we call AI for us. It's very task oriented. It's something that we have to do care and feeding for. Right. And as much as I hate to say it, it's not self-aware. It's not Skynet. Right. Let's call that what it is. But it is something that is helping us out. But it's known as narrow AI, or it's weak AI. But I think that, from a perspective, whether that be for, manufacturing or energy or however it is, I think we're at a great point, right? In a kind of a pivotal point, right? As we teach more and more of the language models about what's going on within that space, right? That we can utilize AI in a way in OT to be able to help predict and threats, right? And actually see abnormal behavior where we couldn't in the past. And it's mainly because, let's be honest with ourselves, ICS, PLCs, however it is, these are purpose-built systems, right? They do one 100%. Job,
Yeah.
Right. So if I understand what that one job is, and I monitor that one job, and then I see another job come out of it, right, or another type of traffic come out, I can make a prediction there to say that isn't right, shut it down, block it off, do something, right, or restrict it in such a way where, once again, right, remember how I was talking about continuity, and if I lose connectivity, this arm still does its job. Take it offline, let that arm still do its job while I'm remediating that arm, like on site, right? But I think that AI is going to help us with that in ways we never thought possible. And as we move away from narrow AI into more general AI, I really believe that we're going to start seeing threats, and we're going to start seeing or we have an opportunity to see, the industrial industry as a whole really adopting that, especially with these legacy architectures that are there to help make a lot of those legacy architectures robust from a security aspect, right? But we still have to put more security controls in place to be able to, once we identify it, how do we remediate it?
Yeah, that's the part that we still struggle with too, in terms of the response. And everything that, it's interesting when you look at the biggest issue I think that we have in the industrial sector right now with cybersecurity. It's visibility, and AI can play such a huge role in just getting that inventory of all your assets in place. I mean, it seems like sort of a very basic solution, or something that we could use AI for.
Well, I'll be completely honest, right? So my brand, right, my platform that I run on, right, if I was running for public office today, is visibility as security. Because here's the thing, right? If I can't see it, then I can't defend it. If I can't see it, I can't remediate it. If I can't see it, I can't block it. Right? So if somebody's in my environment, this gets me back to that conversation I said before, how do you know you've never had an issue, right? If you can't see it, there's nothing on the planet that you can do about it. And when there's nothing that you can do, then you're absolutely vulnerable. So to your point, right, visibility is our biggest problem. I think AI is going to give us that. But here's the problem. We've got to have the systems in place, right, whether it be on the network or, built into the OT or the IoT, devices that are out on-prem, however that is. We've got to have that, being able to deliver that information back so that AI can actually take action, or at least, make a predictive analysis or something of that nature. And I think that's the number one thing that we're missing, is what in the network, what is there that actually gives us all of that visibility from a device to the network to you name it, right? Kind of aspect to say, there is a problem here. Let AI handle this and tell me what's going on. Right. Yeah. But we got to be able to still see it, and we got to have something piping that data back to us.
Absolutely. Jon, this has been awesome. We've talked about a number of different stuff. And in a lot of these conversations, when we really get into it, we talk a lot about a lot of problems, a lot of challenges, sort of maybe the darker side of cybersecurity. And we know it keeps you up at night.
Oh, yeah.
Let's flip that around. There's also been a lot of positive movement, and we've touched on some of that. What are maybe some of the things that help you get to sleep at night? What are some of the positive takeaways?
So I'll go back to AI real quick, right? So what we're doing with AI, the predictive analysis, the fact that, you don't get a phone call at 3:00 in the morning saying something's going wrong with inside of your network. The fact that we have, solutions out there like SOAR, right? Security orchestration, automation, and response, systems, right? And so forth that can take remediation, from days down to hours, right? You have, the massive, I would say, the massive enhancements that we've made with SIM technology as well, right? I think everybody probably knows about Hadoop, right? When that came out, roughly about 10 years ago, big data, right? We crunched it, right? We've done whatever we need to with it. That's just become an everyday thing now, is crunching data. The fact that we can now see that, we can integrate multiple solutions, and then now we're starting to see more and more, I would say, studies coming out, whether it be from Gartner or whoever, talking about, single solutions are actually starting to prove to be better, right? When you're bringing multiple security platforms together under one umbrella, because now that platform has the ability to crunch that data and actually give you a true positive or a true negative, right? You're not getting the false pos and negs, coming out of that. That's been something that has been life, altering, right? I can remember carrying a pager, right? And, waiting for that thing to go off and being woken up in the middle of the night because something has happened. Or, the other things is that, getting those tickets when I was a security practitioner and sitting in the SOC, but, getting those tickets that says somebody's having slow internet, you had to go chase it down. Now we have tools in place like digital experience monitoring and so forth that allows us to pinpoint where the issue is and being able to resolve it. So it could be a network issue. It might not be a security issue, right? It could just be something in the home internet if they're remote, right? It could be anything across board. But now we know not to sound the flag and saying, oh, we might have a security problem. We now have the ability to deeper investigate that and actually prove, is it a security problem or not? And we can do that very quickly and then remediate it even quicker.
Thanks, John. And for more information on the work he and his colleagues are up to, you can check them out at versa-networks.com. I'd also like to thank you for joining us today, and to catch up on past episodes, you can go to manufacturing.net, IEN.com, or mbtmag.com. You can also check Security Breach out wherever you get your podcasts, including Apple, Amazon, and Overcast. And if you have a cybersecurity story or topic that you'd like to have us explore on Security Breach, you can reach me at jeff@ien.com. For Jon Taylor, I'm Jeff Ranke, and this is Security Breach.